Hi students, hope you all fine. So again I came with one more problem. It belongs to same what we discussed in the previous video, that is nothing but lower limit. How to find out lower limit for the variance for the given probability density function. Okay, so let us see what the problem is. Examine whether f of x equals to 1 plus theta into x to the power of theta, and they gave the limits. X value lies between 0 and 1, that means positive limits. Admits a minimum variance estimator of theta. Okay na, so here they are asking us to find what? Minimum variance. Okay, find the lower limit for the variance of any unbiased estimator of theta from this population. Okay, so finally what they are asking is us to find out the lower bound, that means lower limit of the variance. Okay, yeah, let me tell this problem. See, in previous video, if you see my previous video, there we are having the function probability density function is nothing but here uh, in the sense that in that video, in previous video, theta into f of x equals to theta into e to the power of minus theta x. This is nothing but exponential distribution PDF, isn't it? So exponential distribution. So exponential distribution, no, so that's why here we did not check whether it is a proper probability density function or not. We did not check. Why? Because it is a formula for exponential distribution. So at the time, no need to check PDF properties. Okay, but here if you see f of x equals to 1 plus theta into x to the power of theta. So this does not belongs to any formula, any PDF function of any distribution. So that's why first we have to check whether it is a proper PDF or not. So in order to check proper PDF or not, we have to check two formulas, that is nothing but f of x greater than or equals to 0 or not. We have to check this one, and also this is, as this is a continuous function, why? Because they gave limits, no, so as this is a continuous function, we have to check integration limits f of x dx equals to 1 or not, we have to check. Okay, these two properties we have to check. If these two properties satisfied, then we can say that this is a verified PDF, so that we can able to continue the other steps. That means nothing but to find the lower limit of the variance. Okay, so let us check first. To find the lower limit for the variance of any, whatever they gave, that only we are writing, of any unbiased estimator of theta, we proceed the following steps. Okay, or we can follow the following steps. We can follow the steps below. So you can write whatever you feel. Okay, yeah, let me check first whether this is a proper PDF or not, that means probability density function or not. Okay, so to verify that f of x is a valid PDF or not. Okay, PDF in the sense what? Probability density function or not. Okay, so first property what we have to check is, okay, we can keep here A. What we have to check is, we have to check whether this is positive or not. So first is non-negative, we are going to check non-negativity. F of x greater than 0. See here, f of x greater than or equals to 0, we have to check. Yes, it is greater than or equals to 0. Why? Because here they give the limits 0, 1. That means x value lies between 0 to 1. That means it is a positive. That means it is greater than or equals to 0. So that's why first property is satisfied. Okay? Satisfied. Okay? Since given x value lies between 0 to 1. It is given in the question itself. So that's why we can directly say that it is a non-negative function. Next, second property, normalization. Normalization in the sense what? We have to prove that the function is equals to 0. Normalization we are going to check. That is integration 0 to 1. F of x dx equals to 1. We have to prove. Why we here I took 0 to 1 in the sense. Here in the question itself they gave no limit. So that's why I took 0 to 1. So what is f of x function? 1 plus theta into x to the power of. So 0 to 1. 1 plus theta into x to the power of theta dx equals to 1. Okay. So here with respect to dx we are doing. That means 1 plus theta is a constant. So 1 plus theta integration 0 to 1 x to the power of theta into dx equals to 1. So it is in the form of what? X power n. So x power n integration is nothing but x to the power of n plus 1 by n plus 1. Okay? Yeah. So 1 plus theta into x to the power of, in place of n we are having here theta. So theta plus 1 by theta plus 1. Limits are 0 to 1 equals to 1. Okay, so see here, upper limit and lower limit we have to substitute. So 1 plus theta into x to the power of, here these are what? X limits. So that's why 1 to the power of theta plus 1 by theta plus 1. Okay? Minus 0 to the power of theta plus 1 by theta plus 1. Upper limit minus lower limit equals to 1. So if you see here, 1 to the power something. So if we do how many times the 1 to its power, it becomes 1. So that's why finally 1 plus theta into 1 by theta plus 1 minus 0, isn't it? Equals to 1. So see here, example I am going to tell. Theta, in place of theta I am taking 1. So that means 1 to the power of 1 plus 1 is nothing but 1 to the power of 2. So 1 to the power of 2 is nothing but 1 into 1 is nothing but 1. No? So here theta value if you take 100 also it comes 1 only. Yeah. So finally 1 plus theta into 1 by 1 plus theta or theta plus 1. Both are same now. So equals to 1. So both the values gets cancelled. Okay. So therefore 1 equals to 1. That means what? Normalization property is satisfied. So satisfied. Okay. So two properties are satisfied. So now what we can say? Now the given f of x is valid probability density function. Okay, so now we can go to regular process. That is nothing but lower limit they ask. No, so lower limit is proved by using what? Cramer Rao lower bound method. Okay, na? Yeah. So we use Cramer Rao lower bound method to find lower limit of the variance. Okay, so we can use this method. So now, so in this Cramer Rao lower bound method, the first step is determine the Fisher information. Okay, Fisher information. So what is Fisher information? So Fisher information in the sense I of theta equals to minus expectation of dou square by dou theta square log of f of x we can write, or else x comma theta also we can write. Okay, so that means what? We have to do first log of f of x, and after that we have to derivate the function 2 times. Okay, so first step is we have to apply log for what? Given PDF function. Okay, so applying log and finding derivatives, this method is nothing but if you follow my previous videos, we have did many problems. I think 2 to 3 problems we did. That is nothing but which method? Maximum likelihood method. Okay, yeah. So now first we are going to apply log. So for that given function, what is given function? Given function is nothing but f of x equals to 1 plus theta into x to the power of theta. So now apply what? Log. Okay, apply log on both sides. So log f of x equals to what? Log of 1 plus theta into x to the power of theta. So it is in the form of log a b. That means what? Log of a plus log b. Okay, so that equals to log of 1 plus theta plus log of x to the power of theta. Okay, so this is nothing but log f of x function. Okay, so now what we have to do? We have to differentiate this one. Okay, so now differentiate the above term with respect to what? With respect to, here we want theta, no? So that's why with respect to theta. So that is nothing but partial differentiation, we can say this one. Okay, partial differentiation. Partial differentiation. So that means dou by dou theta log of f of x equals to what? Dou by dou theta. Log f of x is nothing but this one. Log 1 plus theta plus log of x to the power of theta. Okay, so I am going to split. That means differentiation I am going to split for both the terms. So dou by dou theta into log 1 plus theta plus dou by dou theta log x to the power of theta. So if you see, it is in the form of what? Log x. Log x differentiation is nothing but 1 by x. Okay, so that means what? Log 1 plus x is, the derivation is 1 by 1 plus theta. Okay, plus here with respect to theta we are going to do now. So theta becomes what? 1. So that means the final answer is nothing but, here we get the final, this one we can write what? Log x power n is nothing but n log x we can write, no? So theta value here we are differentiating with respect to theta now, so it becomes 1. The final value will be log x only. Okay, log x. So this is what is the value of this? Dou by dou theta into log of f of x. Okay, so now what we have to do is, again we have to differentiate this term with respect to theta. Why? Because here we have to substitute dou square value. Okay, so that's why again we are going to differentiate this term. Okay, yeah. So second derivation we are going to do. Again differentiate, partial differentiate the above term with respect to theta. So that is nothing but dou square by dou theta square. Let me show. Dou square by dou theta square log f of x. Okay. So again we have to do this one. Second time derivation. So I am going to split this one. Dou by dou theta of dou by dou theta log f of x. Okay. So what is the value of log f of x? Value is 1 by 1 plus theta plus log x, no? So dou by dou theta into 1 by 1 plus theta plus log x. Okay. So this dou term I am going to split for both the terms. So dou by dou theta into 1 by 1 plus theta plus dou by dou theta into log x. So that is nothing but, so differentiation of 1 by x is nothing but how much differentiation of 1 by x? 1 by x differentiation is minus 1 by x square. Okay, so I will show you. 1 by x we can write in the form of x to the power of minus 1. So it is in the form of x power n. So differentiation for x power n is n into x power n minus 1. So in place of n we are having what? 1. So 1 into x minus 1. So that is nothing but minus x to the power of minus 2. So we can write minus is there now. So we can write 1 by x to the minus we keep like this only. So in power we are having what? Minus 2. So that's why we wrote here 1 by x square. So that's why directly I told you that 1 by x differentiation is nothing but minus 1 by x square. So that means what? Minus 1 by x square. In place of x what we are having? 1 plus theta whole square plus, here we are not having theta term. So that means what? This value becomes 0. Okay. Yeah. So therefore dou square by dou theta square log f of x equals to what? Minus 1 by 1 plus theta whole square. So this is the value for dou square. Okay, second derivation. So now we have to apply in the regular formula. That is nothing but, so which formula we have to apply? This formula we have to apply. So that is nothing but I of theta equals to minus expectation of dou square by dou theta square, in the sense what? This value. Minus 1 by 1 plus theta whole square. Okay, so what this value becomes? So expectation. So this is what? Minus becomes plus. So that is nothing but, finally we get here 1 by 1 plus theta square. See here, for expectation we don't add any constants, only variables. That means x, y variables only we add expectation. So that's why here we get directly 1 plus theta square. It's theta whole square. Okay. Yeah. And again what we have to do? Now we have to apply the Cramer Rao lower limit. Okay. So Cramer Rao lower limit or lower bound. Okay. It states that variance of theta greater than or equals to 1 by I of theta. If it is a small sample, here n value will be. So that is nothing but, so we can show greater than or equals to 1 by n into I of theta value is nothing but this one, 1 by 1 plus theta whole square. So finally what we can write this one? Greater than or equals to 1 plus theta whole square by n. Okay, so this is the lower bound. That means other than this value, no other term is what? Lower bound for the variance. This is the lower bound. Okay, in the given function, for the given function. Okay, yeah, hope you all understand. So if anyone are newly watching, please subscribe to my channel for latest updates and latest videos. So each and every step I am going to explain you. Clearly I am explaining the correct exact theme of the problem. So hope you all understand. Thank you for watching. Please share, subscribe and also click on the like symbol. Thank you for watching. Have a nice day. And also don't forget to comment which topic you want. Thank you.